Alright, this is gonna be a video on just the general basics of pneumatics. So let's get started. So we're gonna be going over the components, then we're gonna be going over the setup, then the different use cases. So let's get started with components. So you have your pneumatic control module, which is your PCM, your compressor, your relief valve and compressor switch, your gauge, your regulator, tanks, tubing and fitting, solenoids, manifolds, shutoff valve, and your cylinders. So this is a PCM, pneumatic control module. This is the brains of the whole operation. So it takes input from CAN bus input right here, 12 volt PDP input right here, pressure switch input right here. For output, it has compressor 12 volt output right here. Solenoids can do either 8 single valve or 4 double valve solenoids. And using the VSOL right here, you can either set it to 12 volt or 24 volt solenoids. Compressor uses a motor to suck air from the outside in and then compresses it for your system. The ones that we have for FRC have a max of 125 psi, and psi is pounds per square inch. Relief valve and pressure switch. So the pressure switch tells the PCM when the system is full of air and then turns off the compressor. The relief valve dumps any pressure if it gets above 125 psi, because that is bad for the system. Bad for the compressor, bad for the system. The gauge is just measures the pressure in a certain part of the system, wherever it's hooked up. And you should use a gauge wherever the pressure changes to know that you have the pressure that you want. So that means for most cases you'll have two, one for the tank and one for the working pressure, or the high and the low pressure. Regulators. These use a specific type of inlet-outlet valve that's controlled by a spring, which determines the amount of air that's allowed to move through the valve. And so it uses that to regulate the pressure coming from the tank. And one thing about regulators is when they're set to a PSI like 100 or 60, so if the input PSI is different, it'll still go to either that 100 or whatever it's set to, because with the valve, even if you so like say in a match you don't have enough time to compress all the way to up to 125, you only compress to like 110 psi, but your regulator is set to 60, so then it lets it'll still send 60 through even though you don't have full psi, because that's what that gauge is set to. Tanks, tubings, and fittings, pretty self-explanatory. Tank stores the compressed air that comes straight out of the compressor. Tube just moves air through the system, and then fittings are what you use to attach tube to different components. And we use 1/4-inch tubing and fittings throughout our system. Solenoids. These are electric switches which control airflow. So they have 4 valves: an input, an in, an out, and a redundant. And an in and an input is different. In is like the different positions for your cylinder, so extended or retracted. and a redundant just doesn't connect to anything. And I'll get right back to single versus double. So this is how a solenoid basically works. So this would be your redundant, and this would be your in and out, in or out, depending on what position you want to start your cylinder at. And this would, so in the off position, your solenoid would be, it'd just be, in the off position, you would have one valve on the redundant and one on your system. So then the system is closed. It's closed on the position that you started at, whether it's in or out, extended or retracted. And when you turn it on, the valves shift. So one valve is on the in and the other is on the out, or vice versa. And when the cycle is completed, the opposite operation is in action at the moment. So then if this was your extended position, then this would be retracted. If this was your retracted position, this would be extended. And so the difference between a single and a double solenoid is that in a single, both of these valves move at the same time, controlled by the same solenoid. In a double, these valves can move independently. So what that allows you to do is change your like basic default. Change this. And some reasons you'd want to do this is when your system is in the loop, it's not going to be as rigid as it is when it's in the closed system. So if you need like something to be stowed away at the end of the match when you're like climbing, then you'd use a double to change from out to an in. And yeah, I think that just about covers it for solenoids. And something about solenoids is that the valve and the electronic part are separate. So what this allows you to do is use these things called manifolds. So manifolds, they're just a line of a bunch of different solenoid valves put together, and they share one input and redundant valve. And so this simplifies your pneumatics a lot, because you have one centralized hub where all your cylinders come back to. One thing though about a manifold is that airflow gets restricted inside of them. So you can't. So if you have two, like say you have two cylinders that move at the same time, you can't hook. I wouldn't recommend hooking them up to just one in and out. I would use two different ones. And then the shutoff valve just releases all the pressure from your system. Oh, and cylinders. So cylinders, there are two determining factors. There's a stroke in the bore. The stroke is the length of the shaft, and the bore is going to be the thickness. And so the bore determines the force that your piston acts with, and I'll get more into that. There are only two positions, so keep that in mind. You only want to use them when you have an A and a B, but you can use rod ends to help pivot the end, making the actions a lot more fluid. And so the setup for pneumatics. So you have your high part. Everything in the blue is going to be your high. And so that's going to be your starting. The compressor is going to get up to its max, 125. You're going to have a gauge here to make sure it's at that. And then this is going to be your tank that's going to store the amount of pressure that you need for your system, however much it is. And then it goes from that to your regulator. And so you set your regulator to however much PSI you need it to be at. And you have another gauge here to make sure it's at that correct PSI. And then from that, it goes to your valves and your solenoids. And then those distribute it to the cylinders. I hope this makes sense. It's a bit, I don't know if I'm doing a good job at this, but that is basically how it works. And then you'd have a shutoff valve like somewhere here, just gets rid of all the air from the system. So there's a bunch of different ways you can set this up. Here's one where the relief is right here, the switch is right here, and then they have a shutoff right here. So it goes into the tank stores it. This gauge is the high pressure, this gauge is the low pressure, the working one. And and then from there it goes to the solenoid, and then from the solenoid it goes to the cylinder. This is one where the switch is right here on the compressor, instead of being on the release. Here is one. This is our pneumatics from this year 2020. We use the Automation Direct Mini Pneumatics. So you can see here, it goes from the compressor all the way up to the tank. From the tank, it goes through this mini pneumatic system. So here's the gauge for the high, goes through the regular, and then here's the gauge for the low. And from that, it goes into a manifold that is right here. And then the manifold distributes it to the rest of the cylinders in the system. So some of the different use cases for cylinders. So one advantage of cylinders is they can't burn out. If too much force is applied on them, they're just not going to extend. One thing you have to keep in mind though is they don't like being bent, disformed in any other direction than the direction that they extend and retract. So, and when they bend, they become useless. You got to replace them. So keep that in mind. It's a controlled force throughout. So with motors, sometimes you'll lose power to heat. You'll lose power in different spots. But with the cylinder, single action, you know the force that you're getting. So you get high speed with a low force. You get a low force, or you get a low force with a low. Oh no, this should be a high force. My bad. This is high force with a low speed in the same system, depending on what the load is on top of the cylinder. And then you have two different positions. So you have an A and B. So anywhere where it's just two positions, it's a lot easier to just use a cylinder versus a motor. Just simplifies your system, makes it a lot easier. And they store energy without electricity. So if a motor got cut off, it couldn't be running. But if you already have your pneumatics, if you already have it set up to the correct compression and your pneumatic system is online, then you don't need to add any force to it. It indefinitely provides force, provided that there's no leaks in your system. And so here is the equation for the force, the push and pull, and this is where I said I'd get back into the. So the bore determines your force because the area that is being pushed, because that is the area that's being pushed. And based off of this, you're already going to know your pull is going to be less force because there's less area, but the equation for this is pressure times area equals force. It's pretty self-explanatory. So, yeah, this is pull, this is push. I think that is it for pneumatics. I guess leave any questions you have in the comments or email me. And with that, we will finish this.